All right, so here's a projectile motion problem. And we've talked about this before, but yeah, definitely one of the most common applications, one of the most useful applications. So it says consider a ball is thrown straight up. Parabola shows that the ball was thrown from a height of, so where did it start? And this is where our y-intercept comes in. Okay, so it's going to be 2, and then it's feet, right? Our units. So it's 2 feet. All right, so it reached a maximum height. So our maximum, right, remember, is our k, the y value of the vertex. So we come across here, it's a little more than 8, so here's 9. So closer to 8 than 9, so maybe 8.2, right? So we'll call that 8.2 feet, right? And yeah, it says about there, right? The maximum height is located at the vertex of the parabola, and the ball will hit the ground about, so it hits the ground right here. So this is 1.25, so it's between 1.25 and 1.5, so maybe like 1.3 seconds, right? Okay, so it says note that the graph shows height versus time, not the path of the ball. And we're assuming no when the ball will fall to the ground in the exact location it was thrown, right? So this one's going up and down, so it's not going, it's not going way anywhere beyond where the vertical path, right? It's not going out horizontally, just vertically. All right, so this kind of is opposite of what we've done before. So in the past, we used our projectile motion formula, and remember we used, let's see, f of x or f of t equals negative 16 t squared plus v naught t plus, it was s naught, that's what we used. All right, and instead of f naught, we'll call it, or instead of f of t, we'll just call it s. And so s represents height, s naught is initial height, and so forth. So before we started with this, and we were able to plug in v naught and s naught, and sometimes s, and then solve for t. This time we're given the function as a graph, and we're able to decipher what's what, right? What are the key features? And kind of like we talked about, we know the y-intercept, the vertex, and the x-intercept. Those are the key features that help determine where we throw the ball from, where the maximum height is, and where the ball hits the ground, or how long it takes for the ball to hit the ground. All right, so here's an example that has where it gives us the initial velocity, right? Velocity is 64 feet per second, so that's our v naught from a height of 5 feet. And so let me use a different color there. So that means that's our s naught. It says what is the maximum height reached by the ball? Okay, so we want the maximum height, which is k. Remember, it's the y value of the vertex, right? All right, so let's plug in stuff where it goes. So I'm just going to start out by writing s of t equals negative 16 t squared plus, and then for v naught, 64 feet per second. So I'm going to put 64 there, t, plus s naught, which is 5. All right, so let me fill in these blanks. We're already going to wrote this out, but just to see, S naught is 5, and then T we don't know at this point. So let's find out. So I can identify A, B, and C. So A is negative 16, B is 64, and C is 5, right? And so if I'm trying to find K, I first need to find H, right? H equals negative B, so B is 64 over 2 times A, which is negative 16. All right? So it turns out to be negative 64 divided by negative 32, which equals 2. Okay, so H is 2. So now to find K, I'm going to plug into, let me use S of 2. So I'm going to find S of 2, which means I'm going to plug in 2 for T, right? So it's going to be negative 16, 2 squared plus 64 times 2 plus 5. All right, and so then negative 16 times 2 squared, that's negative 16 times 4, which is negative 64, plus 128, plus 5, and that'll equal 69. And we're talking about feet, so that's the maximum height. Okay, so that's the answer for this question. What is the maximum height reached by the ball? And by the way, what H represents, even though they're not asking for this, this is telling us how much time it takes to reach the maximum height, right? So the H is the X coordinate, or the, in this case, the T, right? And so, so 2 seconds is how long it takes for the ball to reach the maximum height, and the maximum height is 69 feet. All right, so summary, draw a picture if applicable, define your variable, write an equation, solve the equation, and then we check to see if your solution is valid in the original problem. To see if there's an extraneous solution, like if there's a negative and you're talking about the length or width of a rectangle, then that's not gonna work. So, all right, and then sanity check.